When I write that out, if you know that, you now know everything you need to know to do this whole unit, including the two new things. If you actually understand what exponents mean, then you can do everything with them. If you are willing to write it out. If you are lazy and those 9 rules are too many things to remember, then you're going to be in trouble. But if you can do this, you are in business. Okay? Let's remember, yes.
Is this on the test tomorrow?
No, the test tomorrow is only on radicals. Okay? This, of course, equals 343. And we all remember how to find that on our calculator. We need to use either the X to the Y button, the Y to the X button, the caret, or lately I've seen on calculators, because people are too unintelligent to understand this notation, I have seen this on calculators lately. X with a blank. It hurts me that our society has become so unintelligent that we have had to add this to calculators. But we have. So please be aware of how that it works. All of you know that it is 7, exponent button, exponent, and equals. We all are able to do that. You all need to be able to do that. But I will remind you of something. In the 9th grade, you used this all the time. Because in the 9th grade, you technically only had to do exponents when you had a number for a base. In grade 10, your bases are going to be variable. Which means the rules don't change, but you are unable to use this button very often in grade 10. Okay? Everybody good? All right. So, let us remind ourselves of what everything to do with this notation is. What is the base? 7. Okay? Now, we all know that the base is the thing that is repeatedly multiplied. Yes? Yeah. I'm not going to waste your time writing that down because you already know that. What I am going to waste your time writing down is where the base lives, because you people make this error all the time. The base is whatever. Now please notice I have used the word whatever. That means it can be a number, it can be a letter, it can be a symbol, it can be anything. Whatever is directly left of the exponent. All right? So, in this example, 7 is the base. Is everybody cool? Mm-hmm. Now I'm going to write something that looks like this in red. In red, now what is the base?
Still 7.
Still 7.
Because the negative belongs to 4.
Okay? Now in blue, I'm going to write a third thing that looks like this. Now what is the base?
Negative 7.
Negative 7. Is everyone all right with that? And in their own words, can they explain why each of these is true? Yes? Yeah. Okay. The exponent is 3. All right? Again, I'm not going to tell you what it is. I'm going to tell you where it lives. We call that the superscript, because it is above the line. Okay? the power is the base and exponent, which in this case is 7 to the third, and that's how we read it. We read it as 7 to the third, or it has a shortcut, which is 7 cubed. Is there another shortcut? Squared. And 7 squared. Everything else doesn't get a special name. It's to the fourth, the fifth, the sixth. Okay? All right. Now, I would like very much to hope that my Honors 10 class can fill in this entire chart without my assistance. The only thing I will remind you of is this. Evaluate means no exponents, if possible. So I will give you a couple of moments to fill this bad boy in. Please attempt to do so. You may talk to each other. Everything on this page, except for this row, is grade 9 math. You should be able to already do this. Go. There are the right answers. In a moment. Possible. There we go. Did everybody do okay? For this second number 9, you could also have done 9 to the first. This also could have been, one of these could have been 9 to the 1. Is everyone okay with this? Everyone remembers how to do this, right? Okay, this is the one that causes the most grief right here. Because it's the negative 4 that repeats to get positive 4,096. Then there's a negative out in front of it, so everything is negative. Everyone cool? Yep. Everybody good with exponents? The easy stuff? Yeah? Okay. All right. Now, hopefully, your grade 9 teacher did not do his or her job. Because if they did just their job, they stopped in grade 9 and never showed you any rules about exponents with variable bases. They only showed you numbers because that's all they needed to show you. Hopefully, your grade 9 teacher realized that the government is stupid and they should show you letter or variable bases. And anyone in my grade 9 class did see variable bases. I hope all of you did. If you didn't, it's no big deal. You're going to see them right now. Okay? So, we will start with the very first exponent law. Remember, exponent laws, you know them with numbers. So, 2 squared times 2 squared. What does that actually mean? 2 times 2 times 2 times 2, which you can quite plainly see is 2 to the 4th, right? And if If it happens once in math, how often does it happen? All the time. So in grade 9, your exponent law was add the exponents when you're multiplying. In grade 10, it becomes this. X to the y times x to the z equals x to the y plus z. Everybody remembers this, yes? Is there anybody that has never seen exponent laws written with variables? Okay, you're cool with it though, right? Because it's exactly the same. Everyone is Gouda? Okay, now grade 9s, you probably haven't seen this, so you got to pay real close attention. You good? All right. You guys are smart kids, obviously, duh. If you're dividing, please, 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 even if you actually know this, I cannot stress enough how important it is to write it out in your notes. Because very soon in grade 10, you are going to be using all 9 exponent laws on one question. So you have to know what they all mean. Dividing. 2 cubed divided by 2 squared. What does that actually mean? You're telling me what to do. I want to know what it actually means. Anybody, I can teach a monkey to do this. I need you guys to understand what is actually happening because, like I say, Parveen, very soon you're going to be dealing with stuff that you need to know why it works. So that's what it means, yes? Okay. And what do you get to do when 2 things are the same on the top and bottom of a fraction? Cancel, cancel, and you're left with 2, which is 2 to the 1. Now, Parveen, what did we actually do? Subtracted your exponents. Easy peasy lemon squeezy, yeah? So in grade 9, you learned I subtract my exponents when I divide. Right? Hopefully your teacher showed you why it works and did not just say, you subtract exponents when you divide. Okay, this is why it works. And of course it means this. X to the y over x to the z equals x to the y minus z. Everyone's still cool, yeah? Okay. Raising an exponent to an exponent. So again, you saw this in grade 9 as 2 squared cubed. What does that mean? 2 squared, how many times?
3 times.
Thrice. And you know from the first law that when you multiply, you add, yes? So that is 2 to the 2 plus 2 plus 2. Math guys are too lazy to write 2 plus 2 plus 2, so what did math guys invent instead of adding over and over and over again? Multiplying. So this becomes 2 to the 2 times 3, which is 2 to the 6th. Everyone is still good. What does that mean in grade 10? X to the y all to the z is x to the y z multiplied. Everyone is okay. Your grade 9 teacher probably said, anytime you put exponents over brackets, you multiply them. Right? Yep. Which is just like all math, isn't it? When you distribute over brackets, you multiply, right? It's nothing new. Then leave. Everyone is still cool? Everyone is still cool?
Yeah.
Okay. The 5th thing you learned in grade 8, or grade 9, a fraction to an exponent. What does that mean? 3 halves times 3 halves, which is 3 squared over 2 squared, which is 9 over 4. The exponent goes everywhere. Right? Okay. So in grade 10, that looks like this. X over y to the z equals x to the z over y to the z. Okay? It's still not news to anyone. Exponent of zero. This messes you guys up, and I don't know why. 2 to the 0 is what?
1.
What does that mean? It means 2 is a base multiplied by itself how many times?
0.
0 times, which makes no sense, doesn't it? Because you want it to be 0, don't you? But what is it? 1. Okay? What is this? Negative 2 to the 0.
1.
No.
Negative 1.
Negative 1. Because 2 to the 0 is the base. What is this? Positive 1. Is everyone cool with that? I am willing to bet that your grade 9 teacher, unless you are Magnus or Ranvir, did not explain why that is true. If they did, good. If they didn't, I'm going to anyway. All right? Here is why this is true. What is 2 cubed divided by 2 cubed? What do you do with the exponents? Subtract. So that's 2 to the 3 minus 3, yes? Which is 2 to the 0, yes?
Yeah.
Okay. What is 2 to the third, really? 8 over what is 2 to the third? 8. What is 8 divided by 8? 1. So if that equals that, and that equals that, then what does that tell us about these two? That they are also equal. Does everyone understand? Do you all understand why this is negative 1?
Yeah.
That is what we talked about on the first page. What is the base here? Just the 2. So this is saying negative the 2 to the power of 0. Everyone cool? Everyone is good? So in grade 10, x to the 0 equals 1. No matter what. You may want to write the other 3. Negative x to the 0 equals negative 1, and negative x to the 0 equals positive 1. You may want to do that. Okay? And that, technically, is where grade 9 ended. Is everyone okay with all of that?
Yeah.
None of that is news to any of you. If your grade 9 teacher was grinchy and had a heart that was 2 sizes too big, he or she went a little bit further. Because the next few things are just common sense extensions of these. Okay? So the next one is negative exponents. So, 2 to the negative 3. What does that mean? It means 2 multiplied 3 times negatively. Does that make any kind of sense? No, it doesn't. You want to say negative 8, don't you? Right? But that is not true. Here is what it means. Watch. What is this? 2 to the 5th over 2 to the 8th. What does that mean? That means 2 to the 5 minus 8, correct? Which is 2 to the negative 3, correct? Now, what does that mean if you actually write it out? What does 2 to the 5th look like? 2 times 2 times 2 times 2 times 2, correct?
Yep.
Everyone agree?
Yep.
Over what?
2 times
2 times 2 times 2 times 2 times 2 times 2 times 2 times 2. Correct? happens here? Cancel. What happens here? What happens here? What happens here? What happens here? What's left up top? No, if 0 was up top, then the answer would be 0.
Oh, well, there's nothing.
What is the number up top? What is the number in math that exists where we don't write a number? 1. 1 over what's down here? 1 over 2 cubed. Because math guys are too lazy to write 2 times 2 times 2. Right? Everybody with me? So you guys are smart kids. If this equals this, and this equals this, and this equals this, then what does that mean about these two?
They're equal.
They are equal. So, what does that mean in grade 10 speak? X to the negative y is 1 over x to the positive y. Because negative exponents do not make any sense, do they? You can't multiply something by itself negatively. Is everyone cool with that? Now, if you only memorize what I just said, you're going to be in trouble. Okay? If you memorize this, you're screwed. Listen to what I said. Negative exponents make no sense. Everybody with me? So if I give you this, 1 over 3 to the negative 2, what do you think that equals? Look at what happened when the negative exponent was in a numerator.
3 to the power 2.
Yes, that equals 3 squared, which is 9.
Yeah.
Does everybody see that? This just grows naturally from this, doesn't it?
Oh, yeah.
If the negative exponent is in a numerator, it has to go to the denominator and become positive. For this reason. If it's already in the new denominator, we remember that negative exponents make no sense. So he must have to come up to the numerator. All right? So that should allow you to make this link. First of all, we're going to write 1 over x to the negative y equals x to the positive y. And then we're going to write the third thing. X over y to the negative z. What does that give us? Again, you already know if you think about it. Are negative exponents something we can have? No. So, if it was just x to the negative z, where would that x go? To the denominator. And if it was just 1 over y, where would the y go? Numerator. And what would the exponent become? Positive, because positive exponents make sense. Is everyone okay with that? To be okay with it, you must, if you understand this, then you shouldn't be having any trouble. Because this shows you why it's negative, and it shows you that a negative exponent in a numerator has to go to the denominator. Everyone's okay there, yes? Right? Which means this has to be true as well. Right? Because this is technically 1 over 3 squared, yes? Right? And this is 1 divided by, got to reciprocate this fraction, 3 squared over 1 times times 3 squared over 1, which is 1 times 3 squared, which is 9. Everybody's cool there? Because we multiply by the reciprocal of the fraction, right? Everyone's good? So this is the only thing that should be causing anyone any trouble. But even if you don't understand why it works, if you understand this, that numerators have to go to the denominator, x goes down, and denominators have to come to the numerator, y's come up, and they must be positive because negative exponents make no sense. Good?
Yes.
Okay. Now, that is new. Okay? And finally, 2 different bases to the same exponent. 2 times 3 squared. You learned in grade 9 to write that 2 ways. You learned to write it as a product of powers, which is 2 squared times 3 squared, right? Which is 4 times 9, which is 36. You also learned to write it using BEDMAS as 6 squared, because 2 times 3 is 6, which was 36. Everyone's cool with that, yes? In grade 9, it made perfect sense, because you always had numbers, didn't you? In grade 10, you do not always have numbers. In grade 10, you have letters. So x, y squared, xy to the z is, in grade 10, you do not get to multiply x and y together. Why? Because they're different bases. So this is x to the z and y to the z. Is everybody good up to there? You've seen one of the 2 new things. Is everyone good up to there? And the one new thing you've seen is negative exponents. Everyone is good? Okay. Get out your calculators, and using your calculator, how will you punch in this power? Tell me the buttons you are going to need to hit. What's the base? 9. The exponent button, exponent. Now how do you do 1/2 on your calculator? Some of you have fractions, so you can actually make 1/2 on your calculator. Many of you are good enough to know that 1/2 is 0.5, but it's also 1 divided by 2, isn't it? So you could go bracket 1 divided by 2, close brackets, and equals. When you do that, tell me what answer your calculator gives you. 3. Everybody cool? Yeah. All right. Now do the same thing with 27, but this time it's cubed, or it's to the 1/3. So it's 27 exponent 1 divided by 3, close brackets, equals. And what does that get you? 3. Now do the same thing with 625. What's that get you?
3.
No.
No. Sorry, pattern.
5. Now look for the pattern. Is there something we have done dealing with exponents or one of its cousins where 9 and a 2 will get, where 3, 9, and 2 work together? It is the square root, isn't it? Is not the square root of 9 3? Is not the cubed root of 27 3? Is not the 4th root of 625 5? 5 times 5 is 25. times 5 is 125. Times 5 is 625. It is true, isn't it? So, knowing what you know that has just been shown to you 3 times, how many times something have to be shown to you to be true in math? Once. Knowing this 3 times has just been proven to you, what rule can you write for this, what I'm about to show you? Everybody okay? Everybody ready? X to the y over z. Look at what you've already done. 1/2 gave me this. 1/3 gave me this. 1/4 gave me this. So what does this give me? Where does the z go? Where did the 2 go? Where did the 3 go? Where did the 4 go? Where did the 2 go? Where did the 3 go? Where did the 4 go? You're getting tested on this tomorrow. Index.
Yes.
That is the index number, isn't it? So this becomes the z root of what? Where did the 9 go? Where did the 27 go? Where did the 625 go? Where did the 9 go? Where did the 27 go? Where did the 625 go? The radicand. And where did the numerator go? It's not written anywhere here, is it? What is the number that we never write?
Oh, yeah.
What's the number in math that we never write? As an exponent? 1. Well, there's a 1, right? Where in this construction, because we dealt with the denominator, we dealt with the base, where's the only place left in this construction for the numerator to go? It can be a coefficient or a power. Right? Well, radicals are related to what? Are they related to coefficients or are they related to powers? Powers. So the power goes up there. So where does the y go? Up here. Does everybody understand? Yeah? Okay, let's see. Without a calculator, simplify all these. Okay, so I have a fractional exponent. Where does the denominator go? You just wrote it down 1 second ago. Index. So I have an index of 2, which is a square root, yes?
Yeah.
Where does the base go? Radicand. 0.04. And where does the numerator go? It becomes the power. Everybody cool?
Yes.
Now, what is that properly? 0.04. What is that? For what? Hundredths. So this is the square root of 4 100ths cubed. Correct?
Do you have to use brackets? Or no?
It's easier.
Okay.
You don't have to. What is the square root of 4 100ths? What's the square root of 4?
2.
What's the square root of 100? So it's 2 over 10. Right? Yes. You're testing on that tomorrow. Somebody in this room knew that, because that's grade 9 as well. 2 over 10 is what as a decimal? 0.2 cubed. So that's 0.2 times 0.2 times 0.2, yes?
Yep.
What's 2 times 2 times 2? 8. But I need how many decimal places?
3.
3. So it's 0.008. All that without a calculator. And that, ladies and gentlemen, is what you need to be able to do in grade 10. You need to be able to follow that long a string of logic. Can you do so?
Yeah.
Great, let's see. What happens here? Where does the 3 go? To the index. So we rewrite this as the cubed root of 27 to what power?
4.
4. Now let's say you don't know the cubed root of 27. Of course you all do because you memorized the first few cubes.
Yes.
What is the cubed root of 27? 3.
Yes.
So this is 3 to the 4th power, which is what? 3 times 3 times 3 times 3, which is 9 times 9, which is 81. Everybody cool?
Yeah.
Still cool?
Still cool.
All right, now start taking all of your exponent laws that you already know and apply it to this new situation. What is happening right here? It's going over a bracket, so what do? You multiply. What is 2 times 1/3? 2/3. So this is 8 to the 2/3. Now apply your new knowledge. Where does the 3 go? Index. What is the radicand? 8. And what are we doing to that entire operation?
Well, then why do it 2?
Squaring it. What is the cubed root of 8? 2, which we are squaring to get 4. Is everybody cool?
Yeah.
Going unts, going tice, going fee times a matey,
Ooh.
which means nothing to any of you because you don't get the joke. It's from an Eddie Murphy gag on Saturday Night Live in 1980. Because Eddie Murphy used to be on Saturday Night Live.
Oh, cool.
Way back in the day. All right. Do you think any of these rules change if the thing looks different?
No.
Of course not. So let's look at this. What do we really got? There's a couple of ways to look at this. You could say it's 49 over 100, yeah? Or you could remember that if there's an even number of decimal places, you can get a square root. Right?
Yeah.
So, 1/2. Where does the 2 go?
There.
Index. What are we taking the square root of? 0.49. To the 1. Do we need to write to the 1? No. All we need is the square root of 0.49. What is it? What's the square root of 49? 7. But I need 1 decimal place, don't I?
Yes.
So what's the answer? 0.7. Just 0.7.
Oh.
Why? Because 0.7 times 0.7, 7 times 7 is 49, and I need how many decimal places? 2. 1, 2. 0.49. Everybody cool?
Yes.
All right. Now, E and F look different, are they?
Yeah. No.
No, why? Have I shown you how to deal with decimal exponents?
No.
No, but what are decimals?
Fraction.
Fractions for lazy people. So, what is 1.5 really? To the 3 over 2, isn't it?
Sure.
And then we know how to deal with that in our sleep, don't we? Where does the 2 go? Index. What's the radicand? What's the power? 3. What is the square root of 16? 4 cubed. What is 4 cubed? 64. Now you guys do the last one.
Thinking.
Thinking.
Think.
Think.
Thinker, Noah.
Think.
And Daddy. Everything up. Noah, why do you doubt yourself? I can't think. That's a dumb thing to do in math class. No thinking. Noah, why must you always not think? Come on, bud. Let's go, man.
All right. What is 0.75 in a format that you know how to deal with without a calculator? Because if this was a calculator, you could do it real easy, right? You just use your Y to the X button. But it is what? 3/4. So this is 81 to the 3/4. Where does the denominator go? Index.
Radicate.
81 cubed. Now, if you don't know the 4th root of 81, which you should know because we just did it, you know it's 3. But let's pretend you don't know that.
Yeah.
What do we do from the last half of this unit that you're being tested on tomorrow when faced with a root that you do not know automatically in your head? Factor it. So we take 81 and we break it down to 9 and 9, 3 and 3, 3 and 3. Oh, there's my group of 4. So the 4th root of 81 is what?
3.
3 cubed, which we know to be
27.
27. Okay?
Okay.
Okay.
I can use a calculator now.
Now, these, why do you have to use a calculator?
Because it says so.
No. Why do you have to use a calculator here? What does this really mean? The 5th root of 8 squared. You know there is no 5th root of 8, do you? Don't you?
Yeah.
Of course you do. Because the biggest thing you can have is a cube root of 8. 2 times 2 times 2. So you know there's no 5th root of 8. So when this is irrational, we must go to our calculator. To evaluate. And how do you punch it in? You have 2 choices. You can go 8 exponent bracket 2 divided by 5 bracket, which I already showed you, or you can use the any root button on your calculator, which most of you don't like using. It's a bit of a pain. It looks like this. It's the X beside in the index. And usually when you're doing that, it's index, then that key, then radicand, then equals. Usually, not always. And when you do that, your calculator should give you something in the neighborhood of 2.27.
Yep.
So you guys try it for B, whichever way you see fit. Try and make B work. Actually, you should probably try and make it work both ways.
Really round up. Or no, that's not round up.
So one way to do this is base, 0.6, exponent, bracket, fitting divided by 7 equals. Cool? Everybody can do that one, yeah?
Yeah.
But it also is the 7th root of 0.6 to the 15th power. Now, you can punch that into a calculator. I'm about to show you how. And I'll show you on both kinds of calculator. On this kind of calculator, I need the 7th root. Right?
Yeah.
So I need to find See, on my calculator, it shows x root. So I need to do this. Go away. We'll just bring it back. Okay, I need the 7th root, 7th. Then I get my calculator button, that thing.
Cool.
So 7th root of what? 0.6. Didn't do the point. 0.6. Enter. And then I needed to do that. Exponent 15. Didn't do the 1. 1, 1, 5, enter. Everybody cool?
Yeah.
Now, if you have this kind of calculator, see how there it is right there on the screen? It's a shift. I still need to put my index first, 7, shift. Didn't take the shift. Seven, shift, that, 7th root, 0.6, 6, equals. Anyway, you hit equals and square and power 15, because my calculator is pissing me off. If you are stuck with one of the worst kinds of calculators for grade 10, the kind that doesn't show you what you type, right? Right?
Yep.
That's a little bit harder, and that depends on the machine. Okay? But it is a combination of those buttons. Parveen. In a moment. Alright? Alright. Listen to me, please. On your outline, we are going to stop there. On your outline, you do not have these two worksheets yet, because these two worksheets are mostly grade 9 stuff. The new thing today was fractional exponents and radicals. So I want you in class with me for the next 10 minutes, work on page 227.
Okay.
Okay?
Okay.
Everybody with me?
Yeah.
Tomorrow, when you walk in the door and you get your little test that I'm giving you 80 minutes for, I'm going to give you these two sheets.
Okay.
When you finish your test, you start on these sheets. When are they due? Woden's Day. All right? Now, I also have an announcement that will take 2 seconds. I will not be here Thursday and Friday. I'm going to Victoria with the boys' rugby team because they don't have enough grown-ups on the trip. You are going to have a TOC. I have booked this TOC in advance. She is an actual math teacher. Yes, you are not getting an elementary school music teacher who doesn't know that letters can be numbers. You are getting an actual math teacher. So she will do one lesson. I will leave a quiz or a worksheet for the other day. I don't know which it'll be yet. It depends on how Wednesday goes. Okay? So she will teach you one lesson from your notes with the same notes. I'm going to email her a copy. Okay? Hopefully I get that woman because I'm going to email her the work. If I don't, I don't know what the hell's going to happen. But whoever I get is going to be paid $300, so they better do something with you. Okay? Go.
Okay. Go.
Supreme. Somebody already asked. I don't care. Go.
June 27 makes no
Yes.
sense. There's no 3 or 14.
I'm sorry, what?
Are we being close at all in the number system tomorrow, or is it just better?
There's a little, like, 3 questions on the test on that. Yes.
Let's do work.
Yeah, it actually went like under your glasses.
Yeah. I don't like going flies do that.
I know.
It